All right, 8th graders, quick little lesson for you today. It's 2.5 and 2.6 thermal energy. Your learning targets for the day are I can identify systems in equilibrium and I can model the transfer of energy. All right, first little part, please add key concept number 7 to your notebook. The molecules of a system will transfer energy until the system reaches a stable state known as equilibrium, in which all of the molecules are moving at about the same speed, which also means they have about the same kinetic energy. So all the molecules in two samples would have the same kinetic energy. All right, here's your warm-up today. So I'm going to think about equilibrium. Below are visual representations of 3 pairs of samples, A, B, C and D, E and F. The samples in each pair are in contact. So based on your interpretations of the diagrams and your knowledge of kinetic energy transfers, label each pair of samples as at equilibrium or not at equilibrium. Remember that the definition of equilibrium is a balanced state at which a system is stable, such as when 2 or more samples are at the same temperature. Okay, so that's just an example. It could be the same kinetic energy, whatever the case. Refer to the key concepts posted to the classroom wall if you need help. And when you have finished labeling the images, complete the sentences at the bottom of the screen. So you guys will see where those are at. All right, so first of all, we got sample A and sample B. Over on the right-hand side, we have these 2 little images that you can click and drag. So you're either going to choose not at equilibrium or at equilibrium. Okay, so you're just labeling what these 2 pictures, remember they are in contact. Okay, so just one of these is correct. Okay, moving along, we have sample C and sample D. Both are at 48 degrees Celsius, so at equilibrium or not at equilibrium. So go ahead, click and drag one of those onto the little box to label this system. And then finally, we've got sample E and F. So you guys might need to do a little math for this one. So the average kinetic energy of the molecules that make up sample E, so go ahead and calculate the average there. And then the average kinetic energy of the molecules that make up sample F is, calculate the average there. And then once you guys have done that, go ahead and drag not at equilibrium or at equilibrium up to represent this system. Okay, so that's a pretty quick little section for you. Next one is modeling. Okay, so traditionally I've used this before as a quiz. Don't think I'm going to use it for this issue, but I do want you to make sure you guys follow the directions. So the model on the next slide shows 2 different objects. So we've got a top and bottom are before, with each 6 molecules of different kinetic energies and different temperatures. Use the 2 after boxes to predict what would happen if those 2 objects were pushed into contact with each other. So let's go ahead and take a look at that, and then I'll come back to your guys' steps. So you guys can see here is object 1 before and object 2 before. Notice how they are not quite pushed together yet. So this would be maybe the very first second that they touch. Just what do they look like before? Okay, so you guys are pushing these. You can see that before they were pushed together, all the 6 molecules in the first sample had a kinetic energy of 1. And you guys can see where the temperature was on that sample. Okay, then on sample 2, you guys can see all the 6 molecules had a kinetic energy of 5, and you guys can see where the temperature lied on that sample. And then if we were to push them together, I want you guys just to use your draw tool, but you guys are going to show me in this box what the energy transfer looks like. So you guys either going to draw an up arrow, a down arrow, or if there's no energy being transferred at all, you guys would draw an X. So use your draw tool to show me, all right, when these 2 are pushed together right at the very beginning, what happens? Okay, are we transferring this way to this way to this way, or is there no energy transfer taking place at all? Okay, after they've sat for a while, then you're going to model what those look like. Okay, so let's kind of go back up and check off our instructions. So in the small box between the 2 before objects, draw an arrow to show which way the energy would transfer, if there will be an energy transfer, or draw an X if no energy will transfer when the object comes into contact. Okay, next one. In the 2 after boxes, draw 6 molecules in each and label them with a 1 through 5 to show each molecule's final kinetic energy. So after they've been pushed together and had some time to reach equilibrium, what would those look like? So you guys can either use the draw tool to draw your 6 molecules, and then in them write which number you guys think they would be. Remember, at equilibrium, they're all going to have the same number. So whatever number you decide to use for those molecules, make sure it's the same for all 6 of that sample. If you guys don't want to do the draw tool, you guys can come down here and just click and drag 6 molecules. There's plenty for you guys to use, whatever you need. Okay, so that is your other option there. There we go. Get those back over there. So you guys can click and drag however you need. And then finally, you guys will do your final energy transfer and do your temperature. So let's kind of go back up to our instructions. Step 3, fill in the thermometer to show the final temperature of each object. So you guys have these 2 blank thermometers. So you guys are gonna go ahead, maybe use the highlighter, whatever, I don't care. And you guys are gonna look, these are your options for your temperature right here. So based on what you guys saw before, what you guys saw after, where would your guys' temperature lie? So you guys can kind of fill in as best you can, or you guys can just do a little line saying, all right, my temperature would come to right here, or right here, or right here, and kind of let me know where that increment is going to be. And then finally, you guys are going to do your energy transfers on the last spot. So you guys have this box right here. After they've sat together and reached equilibrium, what will the energy transfer look like? Will it be transferring from the top box to the bottom box to the top, or will there be no energy transfer at all? Okay, remember this is your after is your equilibrium, and before is when they're just originally first put together and coming into contact. Okay, all right, so moving on from that, that was your last little modeling. And then you guys are going to answer these quick questions here. In substances with higher kinetic energy, the molecules move. Here are your 4 options. So the first one will be what fills in the first blank, and then the second word will be what fills in the second blank. So just multiple choice. Use your highlighter maybe to highlight which option you think best fills in those 2 blanks of this sentence. And same with this one, multiple choice, use your highlighter. What is temperature? Is it how hot or cold an object is, the average kinetic energy, average potential energy, or difference in potential and kinetic energy? So one of those options is correct. So highlight or circle which one is the correct answer, answering what is temperature. Finally, calculate the average kinetic energy of the above substance. So here's all of our molecules in that substance. Don't forget to do your division. You do not need a calculator. You guys should be able to do simple math on that. And then finally, I want you guys to go to this last slide. It's your critical juncture. Go ahead, right-click that, open your link. Should take you guys into the Amplify Critical Juncture. It looks a little bit something like this. Go ahead and answer those 12 multiple choice and your 2 written response. And then you guys are all done. Fill out your wrap-up. Do you have any questions? Circle yes or no. If you guys have any questions, type them in right here. But if there's anything that's preventing you from completing this assignment, make sure you guys let me know. Okay, and then finally, 4, 3, 2, 1, how do you think you did? I hope you guys are having a wonderful day, and I will talk to you soon.